Okay, we are going to solve practice problem 6.12 from Sadiku book, and we are given that I1 is changing when time is changing. So I1 is a function of time is equal to 0.6 e to minus 2 multiplied by t, and then I0 is 1.4 ampere, and we are asked to find first I20 and then I2t and IT, V1t, V2t, and Vt. So let's see what the circuit tell us. So here, let's name this node A and name this node as node B. Okay, take a look at node A. If we apply KCL, we will have that I is equal to I1 plus I2. This is at node A. And at node B, I1 plus I2 is equal to one current again. So that one current is equal to I. So here we will have I. So now we are asked to find I0 first. I mean I20 first. I20, and we are given this two. We know that I0 is 1.4 ampere. This is given by the problem. And we can find I10. How to find it? I10. We can just plug 0 to this function, which is 0.6 e to the minus 2 multiplied by 0, because we substitute t with 0. So we will have 0.6 e to the minus 0, or e to the 0, which is equal to 1, and we got I1. 0 is 0.6 ampere. And now, lastly, we apply KCL. Now, I is equal to I1 plus I2, and that is also valid for any time we are given. So, I0 is equal to I1 0 plus I2 0. Okay, so now I have I0, which is 1.4 ampere. And then I10 is 0.6 and plus I20, which is the unknown. So we can move this to the left hand side. So I will have 1.4 minus 0.6 is equal to I20. So I will have I20 is equal to 0.8 ampere. So this is the answer for problem A. Okay, let's save the value. So I20 is equal to 0.8 ampere, and this also important. This value is also important. I10 is equal to 0.6 ampere. Okay, now I will clean the board to get a better space. Okay, so far we have found that one of the variable that we asked is here. So I20 is 0.8 ampere. Okay, now I will not proceed to B first, but it is easier to find this one first, V1t, the function of V1t. So I will find this first, and we can infer what can we get after that. So let's do problem C first to find V1, which is a function of time. Okay. Now we need to take a look at this 600 inductor. Okay. Now take a look. at 6 Henry inductor. Okay, we have this one, and we have that the current that pass through it is this one, I1. I1t is 0.6 e to the minus 2t. Okay, and from here we can calculate the voltage that the voltage across this inductor, which is V1t. Okay, now V1t is given by the formula L d I1 over time dt. Okay, now let's see what can we get here. V1 is what we are looking for, and the L is 6 Henry, so we'll have 6, and we need to find the derivative of some function, and that function is this one, 0.6 e to the minus 2t. Okay, now we will have this 6 multiplied by, okay, exponential function when derived, it will becomes exponential again, exponential function again, but don't forget that we have another function here, so we need to apply chain rule. So we will have 0.6 multiplied by minus 2 e to the minus 2t. Okay, now I will have 6 multiplied by minus 1.2 e to the minus 2t, and so we can get minus 7.2 e to the minus 2t fold. So we have, this is V1t. Okay, now let's save this function because this is important value to save, and we will proceed next. Okay, so far we have this one, V1t is minus 7.2 e to the minus 2t fold, and for the next one I want to find this value, I2, which is the current that passed through the inductor that parallel to our 6 Henry, which is 3 Henry. Okay, so first let's do B to find I2, which is a function of time. So far we have this V1t. So remember that V1t is a voltage across this one, across this parallel inductor. So this V1 will be the same between this 6 Henry inductor and this 3 Henry inductor. The voltage will be the same because it is parallel circuit. So we need to take a look at 3 Henry inductor. Okay, I have the voltage in between across this 3 Henry inductor is this one, minus 7.2 e to the minus 2t. So let's write that. So V1t is equal to minus 7.2 e to the minus 2t volt. Okay, and then V1t, if we take a look at this 3 Henry resistor, it will equivalent to L d I2, which is a function of time, divided by dt, and this one will be minus 7.2 e to the minus 2t. And now our inductance is 3 Henry, so we can just plug 3, and we will have di2t over dt is equal to this function. Okay, so far so good. So now we just need to divide this. So I will have di2t over dt is equal to minus 2.4 e to the minus 2t. Okay, to find this one, we need to integrate both sides. So I will have i2t is equal to integral of minus 2.4 e to the minus 2t with respect to time. Okay, so I will have i2t is equal to minus 2.4 e to the minus 2t divided by minus 2 plus some constant, or we can rewrite this as 1.2, yeah, 1.2 e 1.2 e to the minus 2t. But remember, when we have integration, we will have some integration constant. So we still need to find out what the value of this integration constant. Okay, let's clean the board. Okay, so far we have this function, but we still need to find out this C1. Okay, how? Remember that we have this I20 is 0.8 ampere. So remember that we have I20 is equal to 0.8 ampere, and I20 is this function when we plug 0 into this t variable. So we will have 1.2 e to the minus 2 multiplied by 0 plus C1 is equal to 0.8. Okay, anything with the power of 0 will be 1. So I will have 1.2 multiplied by 1 plus C1 is equal to 0.8. And so I will have C1 is 0.8 minus 1.2, which is minus 0.4. Or our functions become I2 t is equal to 1.2 e to the minus 2t plus this one minus, this is C1, so I will have minus 0.4. Or we can just rewrite it nicely. So I will move this constant to the upfront, so we don't need to write the parentheses. Minus 0.4 plus 1.2 e to the minus 2t, and the unit is ampere. So we have found this I2t. Okay, our journey is still long, so let's do, what can we do now? Okay, now what can we do? We asked to find IT. We are asked to find IT, and remember, by using KCL we can find that I t is equal to I1 t plus I2 t. Okay, now I1 t is this one, 0.6 e to the minus 2t, and then I2 is this one, so I will have minus 0.4 plus 1.2 e to the minus 2t. Okay, so to write it nicely, I will have this one minus 0.4 plus 0.6 plus 1.2 is 1.8 e to the minus 2t. So we will have our IT. Okay, so far so good. So now we already have this one, I2, V1, I2, and I for the answers. Okay, let's clean the board, save the necessary parts, and we will continue. Okay, now we have this one already found, so we will have I2, I2t, IT, and V1t. So two more things to find out, which is V2t and Vt. Okay, now to find out Vt, we need to take a look at this 8 Henry resistor. Okay, take a look at 8 Henry inductor, I mean, not resistor. Okay, so here we have IT is this one given. So we have IT is minus 0.4 plus 1.8 e to the minus 2t. And then we can calculate the voltage across this inductor by using our standard formula. V2t is equal to L, and it is multiplied by the derivative of I over time. So our value of L is 8 Henry. So we'll have 8, and that 8 is need to multiply by d over dt of this one. So we'll have minus 0.4 plus 1.8 e to the minus 2t. Okay, now this is a constant and its derivative will be 0. And for this one, we will have to use chain rule. So I will have 8 multiplied by this one, minus 2 multiplied by 1.8 e to the minus 2t. And then we can just multiply them. So I will have 8 multiplied by minus 3.6 e to the minus 2t. Okay, now I need my calculator, I think. Okay, so I will have minus 28.8 e to the minus 2t. And this is for V2t. Okay, our whiteboard is full. Okay, now let's clean the board and save this value. The unit of this function is volt. So let's save this and put it below this one. Okay, after very long calculations, finally we arrive at our final goals. So we already have all of this except for this Vt. And let's try to find Vt. So Vt is the voltage across all of this. And remember that this is V1 and this is V2. So we can just use V1 over time plus V2 as a function of time. So we can just plug V1 and V2 and add them. So V1 is minus 7.2 e to the minus 2t plus V2 is minus 28.8 e to the minus 2t. And then we can just add them. So I will have minus 7.2 minus 28.8. So I will have minus 36e to the minus 2t volt, and this is our Vt. So we have found this function. Vt is minus 36e to the minus 2t volt. Okay, finally we calculate all the variables that asked in the circuit. Okay, hopefully this will help you to study, and if you have difficulties about understanding my methods, just write in the comments. Let me know if I also made a mistake. Thank you for watching my videos. Do not forget to like and subscribe. Bye bye.